Today's video is on using proportional relationships. The vocabulary for today is indirect measurement, scale drawing, and scale. Indirect measurement is any method that uses formulas, similar figures, and/or proportions to measure an object. The following example shows one indirect measurement technique. Whenever dimensions are given in both feet and inches, you must convert them to either feet or inches before doing any calculations. We want to make sure everything's in the same unit. Tyler wants to find the height of a telephone pole. He measured the pole's shadow and his own shadow, and then he made a diagram. What is the height of the pole? We want to convert the measurements to inches. So AB is 7 feet 8 inches. 7 times 12 gives the feet in inches, and then add the extra 8 inches to get 92 inches. BC is 5 feet 9 inches, so we multiply the 5 by 12 and add 9 to get 69 inches for BC. FG was 38 feet 4 inches, which comes out to 460 inches. And then we find similar triangles. Because the sun's rays are parallel, angle A is congruent to angle F. Therefore, ABC and FGH are similar by angle similar. To find H, we know that corresponding sides are proportional. So BC to GH equals AB to FG. We substitute all the numbers we found in inches for the segments that they correspond with. Go ahead and cross multiply to get 92H equals 69 times 460. And then divide both sides by 92 to get that H is equal to 345. Remember that height is in inches. So if we can write our answer as 345 inches, or we can change it back to feet and write our answer as 28 feet 9 inches. A student who is 5 feet 6 inches tall measured the shadow to find the height LM of a flagpole. What is LM? Convert all the measurements to inches. 5 feet 6 inches is the same as 66 inches. 5 feet is equal to 60 inches. And 14 feet 2 inches is equal to 170 inches. Now we'll use our proportions. We know that our similar triangles are JGH and NLM. Therefore, our proportional statement is GH to JH equals LM to MN. Plug in your segments in inches. 66 to 60 equals H over 170. Cross multiply and divide by 60 to get H equal to 187 inches, or 15 feet 7 inches. A scale drawing represents an object as smaller than or larger than its actual size. The drawing's scale is the ratio of any length in the drawing to the corresponding actual length. For example, on a map with a scale of 1 centimeter equal to 1,500 meters, 1 centimeter on the map represents 1,500 meters in actual distance. A proportion may compare measurements that have units. So we want to find the actual distance between City Hall and El Centro College. To find the actual distance x, we write a proportion comparing the map distance to the actual distance. So 3 to x equals 1 over 300. Multiply across to get 1x equals 3 times 300, and then simplify to get x is approximately 900. The actual distance is 900 meters, or 0.9 kilometers. The rectangular central chamber of the Lincoln Memorial is 74 feet long and 60 feet wide. We want to make a scale drawing of the floor of the chamber using a scale of 1 inch to 20 feet. Setting up proportions to find the length L and width W of the scale drawing, we have L over 74 equals 1 to 20. Cross multiplying, 20L equals 74, and L is equal to 3.7 inches. Next, we find the width by doing width W over 60 equals 1 to 20. So 20W is equal to 60, and W is equal to 3 inches. So now we can draw 3 inches by 3.7 inches, and that would be our base. Similarity with perimeter and area ratios works the same type of way. Similarity ratios start out AB to DE, AC to DF, and BC to EF. And the perimeter ratio will be the same. Perimeter, because it's not multiplying anything, will be the perimeter of triangle ABC to the perimeter of triangle DEF would be the same as the ratio of the sides. The area ratio, however, will be equal to the original scale factor squared, because you're multiplying two things together. So instead of area of triangle ABC to area of triangle DEF being 1/2, it will be 1/4, because that's equal to 1/2 squared. If the similarity ratio of two similar figures is AB, then the ratio of their perimeters is A to B, and the ratio of their areas is A squared to B squared, or AB squared. Triangle ABC is similar to triangle DEF. BC is 4 millimeters and EF is 12 millimeters. If the perimeter is 42 millimeters and the area is 96 millimeters squared for triangle DEF, find the perimeter and area of triangle ABC. For the perimeter, we use the same scale factor. So if it's 12 to 4 for our sides, then the perimeter would be 42 to P. We cross multiply and divide by 12 to get that the perimeter is 14 millimeters. The area will use the same scale factor but squared. So instead of 12 to 4, it'll be 12 to 4 squared. And put 96 over the area. Do the same thing, square everything, cross multiply, and divide by 144 to get the area of 10 2/3 millimeters squared. The perimeter of triangle ABC is 14 millimeters and the area is 10.7 millimeters squared. Try some of these out on the lesson quiz and see if you have any questions. Bring them to class tomorrow or before school, and I'll be glad to help you with them if you had any questions from the video.